Today's chemistry tale is about dilutions. And to do a dilution means to make it less concentrated. And dilute versus concentrated are relative terms. And so if we're doing a dilution, we're taking a solution that is more concentrated. We're mixing it with, in this case, water to make a solution that is less concentrated. So let's take a look at how we do this. I use the equation VUM. Volume 1 times molarity 1 is equal to volume 2 times molarity 2. Now, in this case, is in terms of units, we just need to make sure our volume units are the same. Normally, when we deal with molarity, we need volume in liters. But this is much like one of the gas laws, if you've already covered those. Any conversion we do to volume 1 would cancel converting volume 2. So as long as we keep them the same units, we'll be okay. So in this case, I have an experiment. I need 150 milliliters, I'm going to call that volume 1, of a 1.5, that's molarity 1, and I'm going to use concentrated. When I purchase HCl, I get a big jug of concentrated HCl, and it's 12 molar, so that's molarity 2. So do the math there. I get 150 times 1.5 is equal to my volume 2 times 12. And I got 19 milliliters would be needed. So to make that, I would add water first, and then I would either use a pipette or a graduated cylinder to add HCl. So first add water, always add acid to water, remember. Then I'd add my HCl. Then I would cool it and mix, and then I'm going to add water to the line. So the bottom of the meniscus is on the line. So that's how I would physically make that, and that would be my calculation for that. Okay, you want to be really careful whether the question is asking for the total final volume, as was the case in this problem, compared to how much water would need to be added, how much water is needed. So if we could draw a picture of this, okay, we're going to need a total of 400 milliliters. Now, we always add acid to water. So what we want to know is, of that 400, how much of it is the water that we'll be needing, and how much of it is the 2 molar HNO3 that we'll be mixing. Okay, so pictures can sometimes help. This was asking, up to a total volume, and this is asking how much is added to. So read those questions very, very carefully. So I have 400 milliliters. Oops. 400 milliliters, and I want it to be 0.7500 molar. So I need to find out what volume of my nitric acid solution would I be using. So that's V2 if that stock solution was 2 molar. And so my volume 2, which is the nitric acid solution, is 150 milliliters. So my nitric acid solution, I'm going to need 150 milliliters of that, which means I would need 250 milliliters of the water to make that solution. Again, using a big graduated cylinder, this would be a more qualitative way of making a solution as opposed to the volumetric flask. But sometimes, you know what, it's an excess reagent. It's qualitative is good enough sometimes. So, all right, thanks for joining me. Have a good day.